So I'm waiting for something. Also, is the noise coming from outside or it's fine?
No, sir, it's fine.
Cool, thanks.
And we were just starting, sir. So should we start, sir?
Yeah, let me share my screen. I'm pretty new to this interface. Uh, is it visible to everyone? People? Oh, sorry, I can't see chat yet. Oh yeah, okay, okay. So you will be responding in chats. I mean, you can just unmute yourself and talk. It's fine. Okay. So we're going to talk about basically. It will be a completely non-technical talk. So you are feel free to engage in and interrupt me, have your questions, and try to ask me more questions because it's completely programming free. There will be some technical things, but I will try to simplify all of them as possible. Right. So the agenda will be. Uh, the agenda will be we will understand what is machine learning, right? Why should you care about it? And is the landscape of career here, and then how to enter the machine learning, and then the biggest question, why should anyone hire you? I mean, even if you can enter the machine learning, and then some of my experience, and then we will wrap this up. Make sense? Yeah, hope so. Makes sense. Cool. So I want to give you the definition of machine learning that I gave to myself when I was starting out. And let's take example, right? So in computer science, basically, we have two types of problems. There are problems that have a definite solution, or I can say a deterministic solution, basically. And by the term deterministic, I mean the ability you are able to map your entire logic into the code. And if you are able to do this, then the solution is completely deterministic, right? So let's say you are solving some sorting problem or any kind of programming problem, and you are able to write the code and solve it, then that problem has a deterministic solution, right? You are able to map your entire logic into your code, into the whatever language you are using. But then there are also problems that do not have any kind of deterministic solution. And we take example like suppose you have a blind friend, and you want him to understand the difference between a dog and a cat. It's pretty non-trivial because you will see, okay, both have four legs, two eyes, one mouth, one nose. You maybe can say one meows, one barks. So this is a clear distinction, but not always, right? Not every cat meows. Some very have a very different tone. So as you can see, we are not able to map the entire logic so that our friend can understand, right? I am not able to give a function to my friend that here's the function. Whatever the input you want, just give it to it, and it will tell you whether it's a cat or a dog. That is not happening here. So these are the problems that do not have a deterministic solution, or I can say I'm not able to map my entire logic into the programming language. So what we can do here? We still have experience. I mean, I have experience of 23 years watching cats and dogs, so I can clearly distinguish between them. Maybe my blind friend will take his time and try to smell or understand the sound, whatever. And with the experience, it will be able to make a distinction that okay, such types of things are cats and such types of things are dogs, right? So all these problems that are not directly able to map into a logic, but we have a lot of experience or a lot of data around them, so that throughout the time we can learn what is what. This all these problems are comes into machine learning. Does this make sense? And with the help of this experience and data, what we try is to extract this pattern and teach machines this pattern so that they are able to also understand the difference between a cat and a dog. I mean, just a cat and dog example, but in general, right? And this definition itself answers the why and the where. I mean, why you want to use it? Because you don't have a clear solution. Where you want to use it? Because you wherever you don't have a clear solution, right? Yeah. So this is a definition that I gave to myself, and it's worked out pretty well, and I'm still using it. The next part comes in, why should you care about it, right? When I was in the first year, 2020, the machine learning was still in the hype, and I graduated 1 year back, and machine learning is still in the hype. So you need to care about it because there's a phrase that AI is going to take your jobs, right? And if you understand this phrase, what it means that AI is being used almost all the places, right? It doesn't have a clear field. It can be used along with biology, it can be used along with physics, along with mathematics, along with computer science, right? Any kind of field you can mix with AI. So if this is happening, then there's clearly a lot of opportunities, right? So we should be able to have the correct skill set to leverage those opportunities. So it's not going to eat all the jobs. It also going to create more and more jobs, right? So that's why you should care about it. And where does it apply? Almost everywhere, right? We don't know how silently it is working behind the scenes, and yeah. So any doubt till here? And you can keep ask me anything. You can interrupt me, right? Are we clear till here? Cool, cool. So just keep responding to me, right? I don't want to talk to just images. Yeah. So let's talk about the career landscape. And indeed, you can make a amazing career in machine learning or in AI. It's a huge field. What you might not want to do is entering a zone where you not get recognition, right? That recognition can be in terms of you're not getting the payment, or you not got the authorship if you're in a research paper. So any of things are possible, right? So you want to enter something which gives you recognition and which gives you praise. So I will try to keep it simple. There's a lot of things to understand, but we not might have to go in the deep yet. We just have to cover a very abstract picture of every role, so that in future, if you see these terms in job descriptions or in anywhere, you know what they mean, what they are trying to hire, right? So this career is broadly divided into two sections: the research and engineering. Now you might wonder why research and engineering. The thing is, machine learning is old field. We are doing it from 90s, but even we are still not clear about a lot of things why they actually work. We know they work pretty amazingly, but we are not always sure why they work, and what might be the limitations that they come up with. So all these answers are so important that the research is a very hot topic in machine learning, and a lot of people want to do it or indirectly do it, right? And then there comes the engineering part. Engineering part does not much care about why. It cares about, okay, this thing, so a lot of people are doing their work and they said this thing works, somebody tried it, okay, this thing works. So engineering effort is basically, I will apply those techniques that proven to be work into the problem of my industry or of my own problem, right? So here we're not trying to understand a lot of things, we're just trying to solve things, right? We only care about solution. It works, we're happy. So okay, so let's try to deviate ourselves into the research for more. Um, the research further gets broken into academia and industry, right? The difference is not that much. It just only difference is where you are doing research. If you are doing research under an institute, right, then it mostly academia research. If you are a PhD, you are doing a master's, that probably comes into your academia research. And if you are under industry, for example, like me, I work with Microsoft Research, so I am doing industrial research, right? The work may be overlapping. Maybe both the parties were doing the research on same topic, right? But since they are at different positions, so they have a different title, right? Don't get confused about it. So on a very broader level, if I break down academia, then there will be a PhD researcher. So okay, so tell me one more thing. Are we? Do you all know about PhD or postdoc? Good, good, cool. So, yeah, so good, nice, nice. So, um, machine learning should sometimes demand a lot of educational background, but it's not always true, right? It's just a formal thing, right? So here we have a PhD researcher, then there are postdocs, and then there is a scientist. So PhD researcher means someone who did their undergraduate, did their PhD, and during their PhD they are working with their guide on some research work. The postdoc is someone who completed their PhD and now doing a postdoc under some industry or a college or an institute. Research scientist role, this role, if you see a typical job description, they will care about you have to be a PhD student, but it's not always true. Research scientist role is more care about the experience, whether this person has an equivalent experience. For example, a typical PhD is around 5 years. I'm not a PhD. So if a typical PhD is around 5 years and this guy has a typical 5 year experience in industry, then we count it, right? We count this part. And then there's professors and teaching faculty. So this, I mean, it's a pretty obvious thing in academia, and we all already know about this. If it comes to research, industry research, basically, then industry research has applied research engineer. Again, we sometimes want to focus on the term engineer and scientist. They sometimes overlap, but they sometimes do a very core fundamental different thing. So applied research engineer is something who is, for example, I work, let's suppose I work in Microsoft. Microsoft has some sort of problems they are trying to solve, and there is some working solution undergoing. So the research applied research engineer, I am working on a problem that is being applied to the industry right now. In academia, I might be doing something completely hypothetical, or I might be doing something new that is not being used. But in industry, we usually care about things that, okay, we build these things and we can immediately apply this thing, right, to show the gains. And the job of apparatus engineer is an intermediate job which takes this something that is built. And who built this, we'll talk about it, who built this, but let's say he takes something that is built, he might want to more refine it, or he might want to do something on tweaks of his own, and then he want to apply this to the problem. The applied scientist is the guy who tries to build this thing which is the engineer is using. So he might work very core fundamental level of what this thing is, what the solution might be, and what kind of the limitations, and then he and the engineer together talk to each other and completely build up the infrastructure. The RSDE is called the research software developer. So it's a software developer which works along with researchers, because most of the researchers are not good software engineers. And you might not be able to get the difference right now because you're in the college, but once you have the experience, you will see software engineering is a very core skill that requires writing good programs, monitoring, and everything that not every researchers are good at. So we need somebody who can take responsibility and work with us. And then there's a PhD fellow who is doing a PhD, and they can jump in. Right. Does this tree make sense? You don't have to go deep, just understand what every term means. Just give me a heads up it doesn't make sense. Or if you have any doubts still here. Cool. Uh, Going to the engineering tree, right? Here again, we don't care about the fundamental why. We care about, okay, it works, let me use it. And it gets further broken into a lot of people. And the reason is that engineering is a field which applies the already done research on a huge scale, right? The research scientists might be doing the experiments into some test subjects, some small samples, just able enough to prove that this thing works. But engineering is the effort which takes that something works, expands it, maybe slightly tweak it, and expands it to scale on a thousands of millions of people can use it, right? And there we get a further a tree to machine learning engineer, which is a, you can say, a core guy of every team. He's a guy who knows all the ins and outs. He's the guy who trains the machine learning models, or who train the machine learning systems, develop the pipelines for people to use. Data scientist is the guy who tries to make the intuition of data. For example, let's take an example. Zomato, right? Zomato have a lot of data sets. For example, they know which user order from which restaurants the most, what are the patterns when a certain user tries to do a refund or tries to cancel the orders. So if they have if they have a pattern that they can map, okay, like for example, that okay, this user from my data set, I can map that this user orders a lot from this restaurant, so I can always give him the relevant deals and make the profit. So to yeah, so and the real actual data is very messy, right? It's an entire mess. So the job of a data scientist is to take that messy data set and tries to answer these questions which can help the industry to move or gain more profit. So as an input, he get a very pile of mess and he tries to make sense out of it. The MLOps engineer, yeah, one more thing. So data scientist and MLE, they usually work together because the scientist will say, okay, this solution might work from the data set, and MLE will try to apply those solutions into the pipelines, right? And the MLOps engineer, the role of him is or her is the MLE guy will do a pipeline, will publish a pipeline onto the servers. Whether that pipeline is working as expected or not throughout the timeline, that's the job of MLOps engineer. He will monitor it, he will judge it, he will do logs of it, right? He will keep all the things in check to make sure this pipeline that MLE published is working correctly. And if not, he will inform the downstream team that something is happening there, or maybe if it's sufficient enough to solve it by his own. The ML infra guy is something who set up the entire system for all these people. He set up the compute, he set up the GPU, set up the machinery systems, he set up the software so that every other person can use. So if they get some, let's say data scientists get some internal or system errors, then infra guy is the or team. Infra team is basically they reach out to. Now, this is a very broad structure here, right? Now assume that this industry is a biological industry, which does some experiments on genes or proteins. Then this entire ecosystem will map to their biological industry, or some mathematical industry, or some, let's say, general clothing industries, right? So you can apply AI. What I'm trying to say is apply AI on almost every other field out there. Does it make sense till here? Yep. Cool. And in the bottom line, there is some roles which are again which are not directly, as you can say, somebody who is learning machine learning can understand. These are the roles particularly for people who work on systems, software engineers, but now they want to elevate into machine learning because machine learning has its own core system problems. For example, we also have compilers, right? I mean, if you are aware about some programming language, you will say why machine learning needs a compiler, right? Programming language needs a compiler. Why machine learning? But we do need a compiler. Then there's performance engineers who tries to improve the latency of the system, and then the system research engineers also. Cool. I hope this is good. If you have any doubts, ask me, and we can move ahead to the roadmap. Shall we? Cool. I will drop the link as well. Let me see if I have it. Hmm. Okay, my screen is not visible. Oh, that's so stupid. Okay, I'm share my entire screen. Screen one. Is it visible to you? Cool. So some of you might be already aware because I usually just whenever someone asks me to follow roadmap, I just pass this link. Some of you might already be aware of some parts, but I updated this roadmap. Yeah, let's see. Right. So the first thing I want you all to know, if you're just starting out, is try to get a gist of what machine learning is, where we use it, and how on a very surface level how it works. Right? What in general AI is, and there's also a difference between AI, machine learning, deep learning. Right? It's all a nested structure inside. So I want you all to know this very basic part. It's a very basic things, right? And so this is a pretty free thing on Coursera. It's taught by Andrew Inch, and yeah. So I want you all to take this one. It should be free. It was free at my time at least. So it won't be anything lot of technical. It will be just something that you are learning as a very as someone talking to you that this is machine learning and this is what we do here, right? More like a description of what it is. And after that, the second thing we want to know is we want to learn a programming language because we can't do anything without it here. And I want you to all to learn the Python language. From where to learn? So this is the resource I picked in 2021 when I was learning. Um, you can it's a paid one, so you can feel free to skip it, and there's some free ones if you want to use. I just added it here because I used it. So you need a good understanding of good understanding of Python programming language, and the concepts you need are listed here. At least in OOP. If you don't know what is OOP, it's fine. When you learn from it, you will get, okay, this is OOP, this is generator. Whatever I wrote here, you will get to know when you will follow any of these resources, right? And you have to do this one. The knowledge of programming language is important, and yeah, Python also provides its official tutorials, so you can follow this. They might be not that extensive, but yeah, you can do that. Um, so should I? Okay, I will take the questions in very end, right? If you have a questions. Okay. Sorry. I wasn't looking at the chat. So Kanoj, yeah. So VLSI, if you know NVIDIA, so NVIDIA does use machine learning to try to guess the correct hardware architecture, right? I'm not entirely a hardware guy, but I can give you a sense. So even in VLSI, right, you can use, I mean, you cannot directly use. You need to have a specific systems for that. But yeah, it is possible. People in the industry, they secretly, they don't expose it. It's their own secret sauce. They use the machine learning to derive the optimal architecture of what hardware should be. And if I am correct, then Google also published a lot of papers around it, how you can leverage this part. And Google also does it on their own. So even in hardware industry, you can still use machine learning to predict the correct architecture. And I might be not much clear here because I'm not a hardware guy, but hardware gets a lot of inconsistencies. What FPEs you want to use, floating point units you want to use, and where you want to use, what will be the buffer size, all these things matter. And it's such a big search space to find the correct optimal value. We leverage AI to do it for us, right? So this thing still happens there. Cool. So I will take the questions regarding roadmap in the very end, right? Because it can be a huge thing. But yeah, let's still keep going. So on a very high level, we need to understand what is AI, right? Now, what is AI? Then you want to learn the language, Python language specifically, and then you want to learn some tools inside the Python language, right? For example, NumPy, Pandas, and Matplotlib, they are the must you should have. And when you learn these tools, right, then you can happily move ahead to learn the machine learning, right? Cool. So there is some math prerequisite. um, it's not that hard. I mean, if you are a second year person and you gave some attention to the college, then you're already good to go. You can completely skip it. But in case if you're not, because in my time I didn't, so then I have to read those things. So these are the free MIT OCW playlist where what I used to learn. So the things you need as linear algebra, single variable calculus, then multi-variable calculus, some statistics, not entirely some statistics, and it's an optional thing. You can this is the same thing for linear algebra, but it's an optional thing, right? So you need basically these three fields, at least a basic understanding of these three fields. Should I go in deep? Yeah, let me open them. Yeah. So if I talk about, this is a video that is by Gilbert Stein, and if you're learning linear algebra from here, then I want you to at least learn till till 27. right? At least learn till 27. There are 27 lectures. If you do one lecture a day, you can complete this in a month. And how you are going to do it, that will be talk later. And then if I come to the single variable calculus, I think if you know how to differentiate, you're already good, right? You just need to understand what is a Jacobian, what is Hessian, all these terms. If you're not sure about them, and here, if I was you, then I will do it till complete 38, because it's a very fundamental thing. You might already know all these things from your 12th, right? So it just will be a quick revision. So complete it whole. And the multivariable, this thing might be new to you. If you're not, I mean, it was new to me. So this thing might be new to you. And here also, I want you to at least complete till the mm, change of variables 18, right? You might I mean, the more knowledge always helps, so you can complete it too, but till at least till 18 you should do it. I don't really, I will share this link with you, so you can all use it. Then statistics. So I was very bad in statistics, and I was never able to find a good resources until I came to this book. So this book is hosted from my own Google Drive. Don't distribute it. But yeah, so I know don't people don't like to read from books, but I tried first time and it works really well for me. Yeah, so stat is also a must thing. I mean, you just cannot skip these three topics, these three subjects. You need to have a knowledge about all these four things. um, cool. And when you do, right, right now I'm explaining it linearly, but you don't have to follow it linearly, right? I will explain how to do later. But after you get a good sense of mathematics, you are now pretty much good to directly jump to machine learning. And when you do machine learning, I want to focus on two things. The first thing is, how am I going to clear my interviews, and how I'm going to get the interviews. So these two are different, separate things, right? So in the first section of every section, there's a first of interviews. You should be completing this page to page, or it's not a book, it's a course. So you should be completing everything lecture to lecture, and you should have a very good grasp around it, right? Because in my experience of around 2.5 years of giving interviews, I never got asked anything out of these resources, right? So if you are able to just have a good understanding, right, of what the topic in machine learning I'm learning right now, at least from these sections, you are able to clear the interviews, right? And okay, this its link is this one, right? So this is the one where you learn how to um, pass your interviews, and then you also want to know how to get the interviews, and where then this is the part which requires a lot of effort and practice from your end. So since right now you are just jumped to machine learning from a maths area, from programming area, you are still pretty new to it. I want you to go to this link and do it, right? So back on 2022 or 2023, I forgot the exact year, Kaggle platform had a competition that is called a 30 days of challenge, where in that challenge they basically trained all the participants for 15 days what is machine learning and all the tricks, everything practical, right? And then in the next 15 days we were competing on a data set, on a problem set, right? So this is the now that challenge won't happen anymore, but you can still access the links and still learn from it. So this is where I got my first hands on machine learning, on how to solve the actual problems, because till here I was only following what the instructor was telling me to do. Here I got to do the things that I know, and I'm applying something new, and there's no one to help. Yeah, this is a pretty good experience. So here you will kind of break your that insecurity that you're not good enough, and you might need to learn more. So this will be the part where you break it. And there's also a playlist by the grandmaster. He particularly explained every single thing of the challenge of all 30 days, so you can just follow it too if you want to. Otherwise you can just follow this link, right? It's up to you what type of guy you are or girl you are. Right. And then I want you to focus on the next section of deep learning. Deep learning is basically machine learning, but now we're applying it on an even huge scale. And here, this is again a specialization. It's a set of 5 courses that will help you to clear the interviews. Um, okay, so back at my days, it was used to be free. It will still be free. I'm not sure. And in case if it's not free, then you can follow this book. It's a huge book, but again, you can just filter out the topics from here. You can filter out the topics from this section to this book, right? And you can get this book by going here and download the PDFs. This one, right? And this is a very latest book. It keeps updating, so that's a benefit. Yeah. And yeah, and when you are good till here, you can and you then you can decide to um, follow your own interest. For example, you want to use deep learning in the vision, you can follow computer vision. You want to use just search this term on YouTube, you'll get the link. And if you want to follow this on natural language processing and text data, just search this term on YouTube and you'll get the links, right? And every time you want to do hands-on, I will highly recommend try to compete on Kaggle. Past competitions, they are the solutions of past competitions, and what are the current ongoing competitions that you can also see here. And you can also use the same competitions. It doesn't matter you win or lose, it doesn't matter. Nobody, I mean, winning here requires a lot of things, so just forget about the winning or losing. Just compete here, learn the stuff, and try to see if you can use this as a project. Because these are some stuff that some problems, basically these are problems, right? These are problems that are very non-trivial, that are only an experienced guy can solve. And if you are tackling it on your first day, not the first day, I mean, having some prerequisites, but not tackling it, first thing, it will boost your performance, boost your confidence, and it also give you a respect in eyes of a recruiter, right? So yeah, so you can just do any of this challenge, right? And they keep coming up, people who win get cash prizes and all these things, but you don't have to focus on that part. You just want to compete, get the knowledge, and done. And if you win, that's a very great thing. So this is a whole roadmap. It will take around 6 months if you start or do consistently. Am I not missing anything? I hope I'm not missing anything. Okay, any questions still here? You can ask me, right? Hmm. Yeah, let me know if you have any questions. Are we good till here? Gen AI is just a word that people give you. Everything here, this is Gen AI, right? Um, when you work with LLMs, you are generating something output. It's called Gen AI. So just a term people give you. There is no Gen AI exist. It's term that influencer use to fool people. So don't focus on Gen AI ever, right? Just focus on the core skills first. Yeah, we will go for, yeah, we'll talk about it. And if I say right now, then what I did in my years, I competed a lot here, right? And I used all these competitions as my GitHub projects, except one. I use all of them as my GitHub project. And so these are new problems, right? In my day, there was some else problem, and every time the problem is higher than the standards. So recruiter get a very good eye that this guy is solving something which is pretty non-trivial. Yes, we can. Yes, size we can. We can learn mathematics and MS simultaneously. It totally works. It also depends on how comfortable you are seeing mathematics. If I have to say, for example, in interviews, the interview section, to me, and I think to almost everyone, interviews are usually maths heavy. And when the instructor starts teaching machine learning, they try to make it math heavy. And the reason is only because to to get you more and more comfortable with the equations, right? Those equations might seem huge, might seem very daunting, but all they are doing a very similar fundamental operation. So it's up to you how comfortable you are. If you are comfortable with mathematics, feel free to do both simultaneously. If you think these some symbols are new to you, some terms are new to you, for example Jacobian, Hessian, and whatever else gradients that are new to you, then you can do first those terms and then comes to ML. It works both the ways. Oh yeah, yeah, we'll talk about it. Yeah, we'll talk about it. It feels like I'm watching a stream, but yeah. Cool. So should we move ahead? If you have any questions, just try to unmute you and ask, or just type it here. And I will recommend ask because you might not get any more such deep, abstract, surface level introduction to machine learning. So just use this opportunity. Should we move ahead? Cool. Moving ahead. And don't be this guy, right? Don't skip this part, please. So this is the part when we will talk how to get in the eyes of recruiter, or basically I can say why should anyone hire you. So after your preparation, right? There are some things I want. There's some things that I would like you to not just listen to me, but also try to apply it. Right. First thing is learning is overrated. Right. You might be feeling okay. I'm learning a lot of resources. I'm learning a lot of books. I'm too crazy. People can hire me. No. Right. No. Um, it's a skill, right? That you should have it, and we will discuss the skill in 4 points. For the first point is what should you do after or along with the preparation, right? um, you have to kind of get rid of your introvertism. If you are, you need to know how to sell yourself, right? The skill of selling yourself. There are thousands of people also learning from the same material that you are learning, and you need a factor that distinguishes you from them and puts you more into the recruiter's eye, or at least you get an interview, right? That's the first step. You should get an interview, and all the learnings that you're doing till now will only work if you get an interview. If you don't, everything is waste, right? So I want to do few things along with preparation. We, as I said, we typically follow the roadmap in a linear order. Okay, like okay, Swayam said we will follow the programming language, we will do the maths, then we will do the machine learning, deep learning. Don't do them linearly, right? Because what is going to happen is, in the moment, let's say you are doing, so let's say you already worked on the Python programming language, and now you're jumping into the machine learning or into the maths. There will be some areas of or concepts or syntax that you'll forget, right? If you're following it linearly, it happens to me a lot. So there will always be a to and fro moment. So in order to sort this out nicely, I want you to do every take a window of 1 week. For example, let's say I'm talking to you today, and before 1 week, whatever the things I learned, I'm going to write a technical article around it. I will try to write a blog around it. I will try to explain I learned in that past 1 week in simple terms, right? This way, you will see what are the knowledge gaps that you possess, and it will also resolve all your past forgetfulness to go back and read it. If you don't do it, eventually you will be at some place and you will forget a very initial thing and you don't know at what tutorial it was covered. And you'll be searching to playlist where it was covered, and it will be, I mean, it will be, you may be able to find it, you may be able to use ChatGPT, but I would still recommend to write a topic or write an article around it. And the reason is that, um, from my perspective, I feel like, okay, I learned this topic very well, I can move ahead. But there will always be there will always be some moment, some concept that you haven't grasped completely. And if that happens, and when you're writing around it, you'll feel it. Okay, I don't know much what I'm doing here. I have to go back and learn it more. So it is not a thing to say. It happens, and in my experience, doing this helped massively in my interviews, because interviews usually ask you a conceptual question, a very deep conceptual question that will be around the topic, but you might not explicitly being told. So if you are doing this kind of things, you are for finding your knowledge gaps, you are trying to make the links of current topic and the past topic, you will able to solve the problem that interviewer will give you. And usually they are hypothetical problems. So in order to think hypothetically, you have to feel it. The other thing is, when you write an article, make sure you publish it. Where you publish, it does not matter. You can write a single LinkedIn post around it. Don't be like day 128 of 100 days and whatever people do. Try to make it conceptual, more concrete. That we learned this thing, and now here I'm going to explain it. Right? Try to follow it that way. Just logging out day 28. I learned this and this. It's not going to help, because you're just outlining it. You're not going in deep. You need to go in deep. The other thing is, I want you all to engage more with the community, right? For example, let's suppose there is someone out there who is doing pretty good in their ML career. Reach out to them. Reach out to them directly. Ask them what the things they did in their days. I want you to engage in the comments, in the discussions. Don't be rude that I know what I'm saying. It just give it's a friendly feedback that okay, I understand what you're saying, and here's what I'm saying. Right? Try to engage with the community as more as you can, because researchers are always finding people in those communities. I'll give you a very secret example. If you know about conferences, so every year there's a lot of conferences happens in machine learning, where researchers comes in, they publish papers, and they talk to each other. And at the same time, most or almost every company also hires from this conference, because they are directly getting a lot of people who are engaging in the community, who are having the experience. So if you are someone sitting on inside a room, not getting even enough exposure, it's very rare you get hired, right? So you have to come out, try to engage in community. Even the Microsoft, so the new reps is happening. It's new reps conference. It's happening December 1st to 7th, and we are hiring from there. So like it's a win-win situation from them and win-win situation for us. So yeah, to 2 points. Try to write the things you learned in the past 1 week window every time. Write an article around it and write it in a way that you are teaching it to somebody else. And then also it can be a blog, it can be a just LinkedIn post. You just have to go deep, challenge your current knowledge level, right? And also engaging with the community. Does it make sense? And yeah, and one more thing, like if you let me just give you this thing. If you don't know, come on, cancel. If you don't know where to engage, LinkedIn is the first thing. Like I use LinkedIn a lot to engage. Other things Twitter. But if you still don't know, then come to the discussion forum here, and you can see a lot of people trying to understand the things, right? This guy, some who's young, learned a lot of competition, and then somebody is asking other questions. He's asking a technical question, right? You can come engage here as well, and anything counts, right? You just have to challenge your current level of understanding, right? Idea of concluding the notes of research. You can do it, but the thing is, you're not popular enough that anyone goes to your GitHub. So I usually keep at that time. I usually keep handwritten notes when I was learning in 2021. Um, Now I keep all the notes on my GitHub or Notion. So the thing is, it is for you, not for a public eye, right? I want to know what a public eye sees. A recruiter might not go to your GitHub type your username, follow the entire, reach out to the correct repository, and then see, okay, he's guys collecting a log here. Developers can do, but not recruiters. So in that sense, you need to find a something that is more attracted towards public. LinkedIn is the one place. Twitter can be another place. Kaggle can be another place. And if you want, you can write blogs on your own website if you have our own github.io website, and just try to post about it. Just show people and come in public that say, I did this work. I'm the one who did this work. And I think they were your seniors used to do it a lot. Apurv and other guys, they used to do it a lot. So just try to learn it, right? GitHub, storing things on GitHub can be good for you to access later, right? If you are storing on a digital notes, it's really good to access it later time, but it not might give you the exposure to public. Make sense? Yeah. And don't be feel like that, oh hey, I'm a naive, I don't have much knowledge. If I go out there, I talk to people, they will think it's fine. I reached out to a lot of, in my earlier days, I reached out to a lot of people, and people are humble. So I was very unsure, how can I learn statistics in a good way, right? I was very bad at that. Then I reached to some people, some core maths people on LinkedIn. I told them my issues. I followed these things, and I'm not able to do it enough. They give me a clear path that, hey, you can follow this thing. So people are humble. You can reach out to them. Himanshu from Brain means, okay. Okay, anything else? Should we move ahead? Okay. Yeah. So the first point will tell you a baby steps that you can follow during your preparation or after preparation, right? When you are learning the machine learning. Second point is, I call it the art of faking experience. And see, if you want to get hired, a recruiter will only care about a person who has good amount of experience, right? Now, the thing is, given a certain amount, for example, let's say you are undergrad, so given a certain amount of time, 4 years, which person grabs the most amount of useful experience, and ideally, we recruiter more focus on those candidates, right? The thing is, in industry, experience term has a lot of different meanings. So one experience is how much of industrial experience you have. There's someone who is working on industry, right? And that you will not have ever because you are undergrad. You will only have when you get graduated. So this not counts. This is basically you are showing the amount of work you did, right? The things you challenged, and you are trying to basically create a persona in the eye of a general public that, hey, given this amount of time, I was the one who able to perform more and more things, able to grab more and more titles or achievements, right? And this is called the art of having experience. And it's so powerful that this way you can even surpass the people who are actually having industrial experience, right? People who are actually working in industry, they might not have anything else of their own, they're just working there. And if you have a general more diverse knowledge, you can able to surpass them also. And how to do it, the choice is very clear, right? You have to do some kind of a public image, technical writing. If you are good with camera, YouTube, of course, there's a lot of content creators right now emerging in AI field that are YouTubers. Do a lot of competitions. You can do hackathons, that also makes sense. Competitions also make sense. Anything, because they are both same things. Hackathons typically last for, I think, 24 hours, 36 hours, 48 hours. These competitions, they last till 3 or 4 or 6 months. So you get a huge amount of time window to do something, right? And if you're able to get a decent rank, not even winning, right? Not if you get an under 100 rank, you can just boast about it on LinkedIn, and people actually care about it, right? There's a very good amount of respect toward people who compete on Kaggle, and you need all these respectable things, right? I will later talk about the credibility and the checkpoints that you need, but you need all these things to stand out, right? Something that I have a respect in my eyes, and you have it, I have respect for you. Second question is what to make projects, right? And people also crash here, always crash here. The first option is you can take the same competition, use it in your project. The second thing is what I really want: do not do not ever do more than two projects. Just do two projects in your whole 4 years, two projects, but make sure these two projects are heavy enough to tell a story. Now, what's the story, right? The story I want to hear from a project is that problem really deserves to be solved or not, right? Is this a problem that deserves to be solved, like somebody somewhere having this problem that you're solving? The second thing your project should tell: what are the current solutions around it? So there's a problem that should be solved, then these are the current solutions around it that people use, and what is the limitations of each solution. The third thing your project should tell: how you are able to solve it, how you are approaching it, right? It may be better than others, it may be not, it's fine, but you have to tell how I approached it and how I am unique. And then you are showing numbers. Numbers means how good I am or how behind I am, whatever, you have to show the numbers, right? So if you are able to tell these four-part story in your project, it's best. And there is almost every time there is a dedicated project discussion round in the interviews happen, so you have to be prepared for this. Does it make sense? Let me also show you one example, what I did in my days. Mm, so some of you might have known it. This is the project I did in my second year, end of second year, right, or end of second year. And so the project is, you take a cloth, you take a user, and then my entire pipeline will make your image look like that you are wearing that cloth. So back in 2022, this was a very ambitious project to do, right? Almost, I mean, nobody caring that much at that time. Now there are a lot of tools, a lot of new models, but that time there were none, right? So you need something, a problem statement that stands out itself, and it took me a, a time window of 6 weeks. That means around 2 months, no, yeah, 1.5 months to complete it. So give yourself time, right? Don't be a 1 week or one night project. Take around 1 month, 2 months, 3 months, as long as you need to know that your thing is going to work and it will be a very innovative thing. So it took me around 6 weeks to do it, but that time it gave me so much of credibility, so much respect in towards the eyes of recruiters, that they're immediately able to hire me or immediately want to use this in their product. So you need to pick some project that is not much trivial. You need to have something that tells a story, right? And then you are also able to give the numbers. uh does it make sense? What should to do in the project section, people? Cool, cool. So now you know, now you have a idea that what project problems to look for. Other thing is a behavior thing that I want you to have, everyone. So from now on, none of you will able to think like a learner, right? So just keep the real identity that, okay, I know this much about something. It can be anything, right? I know this much about something. Just keep this knowledge up to you, only to you. Whenever you're interacting in public, interact like an expert, right? Expert, not a rude expert, not an arrogant expert, but just as a someone who is listening, who is getting all the thoughts coming in, and try to add a value. Don't be like, okay, I don't know about it, I will stay silent. No, just try to give some input, try to get some output, right? It's a behavior quirk, and you should apply it on your daily life, and you should apply it like that you get so comfortable that when you sit in an interview, you're able to mimic it. So you are talking to an interviewer, you should be able to talk or have a conversation like this. He should not get any kind of sense that he's talking to a novice or a beginner, right? You should be pretty confident in what you are saying, but you should be also able to get the feedback, right? So these are pretty four things that I want you to do to fake your experience. Make sense or not? And also the last thing comes with comes with habit. So you might have to practice it on your own. I used to do it a lot. Or you can have a discussion with your friends and kind of technical discussions. Try to be as open to thoughts, open to new solutions, but also try to provide your own input in a friendly way, right? Cool. So the third point is building a credibility as undergrad. So if you're following the first 2 points, right, all the points are set in a way that if you follow the last point, you'll follow automatically the first 3 points. So the third point is building credibility means it will already cover the first 2 points, and it's basically a checklist. And I followed this checklist in my undergrad completely. So I want you all to also make sure wherever position you are right now, and as you are getting closer to completing your graduation, you tick mark every single part of this thing. And if you do, I'm pretty sure there will be a no chance that you will not get hired, right? And you might get a even better place. So check mark all these things. I was able to do check mark in 3 years, and in my time resources are pretty low, and right now we have a lot of more exposure, more things coming up, so you might able to do it even faster. But make sure to do it right. So let's get a quick overview of everything. The first thing is our research paper is professors, right? So if you're in your JKIPT, right? So in JKIPT you can get in touch with the professor and ask them that there is a problem, that machine learning problem that you want to solve, and you want them to help you to write a paper. Don't don't be like, I want you to solve it, right? Solve by yourself. You're just taking the name of the professor to help you. That's the one way. Ideally, or you can reach out to the IITs, professor of IITs, professor of ISCs. They are pretty open, right? They are pretty open. You might not get paid here, right? But it's totally worth it. You will get a paper with a name of your own. So what I did in my days, I did a research paper, two research papers with Hugging Face. If you know Hugging Face, I did with them. I skipped the IIT, I see the IDO. But if you can follow any um, published, not published, doesn't matter. It should be on the archive with your name, and this has to be done before your graduate completes. Makes sense? Any question till here? I will cover these points in a very slow manner, so please ask if you have doubt anything. Are we good? Cool. So the second point I want to check is you have a story rich project that we just talked about. If you check this up, very good. The third point is open source contributions. Now you might don't see see it's a two-phase thing, right? Contributing in open source ethically. Don't wait for any program. GSOC, Consite, there's some GSSOC, right? Something those programs. Don't wait for them, right? If you, for example, let's say you came from building a project on your own. If you did it correctly, you already have a pretty good sense of all the tool chains. What language you're using, what tools you are using, what models you are using, you have a pretty good sense. And I'm definitely sure if you are pretty good sense, you will have a pretty good sense of their limitations. Even right now in my work at Microsoft Research, whenever I work with these tools, I found a lot of troubles and issues with these tools. And these troubles are basically an opportunity I can contribute back, right? And this way I contribute multiple times to Hugging Face because I use Hugging Face a lot, and they have some issues. I fix them and I contribute to them. So if you follow the second point pretty well, you'll have a sense. Okay, this tool has these limitations, and I can fix it. It might be a documentation fix, pretty fine, right? You just want to go out there and do the contribution because GitHub profile matters, right? No contribution is big or small. Just do what you think is valid for you and for the community. Does it make sense? Cool. The fourth point is grab an internship. Internship does not it does not require you to have a full-time job experience. Recruiters also hire lightly. You should not aim for a big MNC internship at your first chance. Just intern somewhere. Don't be unpaid. Don't be unpaid. Intern somewhere. Get some experience so that you can use that, right? People, recruiters usually like the internship experiences. So try to get a paid experience. Even the wage is low. My first internship was 35,000, so it's pretty low, right? So even still, if you try to get something around it, have an internship. um, you can get an internship during your ML preparation, right? People are soft here in this area. I hope you're not targeting the big MNCs because they have a very unfair rounds of internships program. But yeah, if you want, you can. If you are capable enough, you can. But otherwise, focus on startups who are newly funded. Go to YC website, search for startups who are newly funded, reach out to the founders that hey, I can contribute to your purpose in this way. Please hire me. They're happy to hire you for 3 month or 6 month role. You get an internship. That's it. That's all you want. It's actually easy. If you have any questions how to get internships or anything like that, you have just ask me in the end of the talk, right? So first, for now, just have a sense that okay, internship matters and we have to get it. Kaggle competitions again, they are respectful. So if you are able to get some things completed by yourself on your profile, it is respectful, right? I remember when I got the title of Kaggle expert in competitions, it it immediately boosted my reach, and people came to hire me or came to work, like asked to work with them. The last part is public facing content. We already talked about it, and hackathons, right? So ideally, you should be able to checklist all, and if not, you should be able to checklist the first, second, fourth, and fifth. First, second, fourth, and fifth, you must able to checklist. Um, so I don't know if you had one question or not, but I had this question: should I pick a research side or pick an engineering side? Right? In a machine learning career. So what I did is I picked them both, and in the end, whatever suits best to me, I flowed with that. So so if I picked the both, I had offers to the both, and in the end, I just picked who pays me the most. Right? So that's the good thing. You don't have to be a specialist. You don't have to be an expert. You don't have to be a perfect. Just be journalist, right? Do everything that's possible. Makes sense. Even if I give you an example, then in the roadmap, basically in the roadmap, yeah, here. So when I was learning, I learned all these things. I had a computer vision NLP I'm still doing, but right now I don't do computer vision much more. The extent got much decreased. I'm more heavily here. So, but yeah, when I was learning, I was good in all these things. So I want you to be also good in all these things. Sounds good? You can move ahead. Okay. So yeah, the last point of why someone should hire you is a structure of interviews. So I try to break this down into these two sections, and let's assume the take home assignment is very obvious, so let's not talk about it much. Screening and project deep dive round. But let's first talk about engineering, right? So in engineering, project deep dive round is a must. It happens every time. Even if you apply for internships, it will happen, right? So that's why I said if you have a good project that tells the story, you will able to extend this round to 40 minutes talking just about the story of the project, and the interviewer will be very happy. I did this personally, and it always worked out for me. You have to start with what problem I thought is worth solving, and give some proof that yes, it is worth solving. What were the current solutions? What was my solution? How unique it was or not unique it was, and the numbers. How much percent I am better, how much percent I'm not better, and where I work, where not work. Right. So if you are able to set up a huge story around this, then your 40 minute interview will be a blast. And this first thing is very pretty common. They will just have an introduction and just work with what work you did, and you start talking about your project. That's it. The third round is DSA round. Oops, sorry. The third round is a DSA round. Now DSA round depends. Okay, tell me one more thing. Do you know about the HFTs? Have you ever heard of the term HFT? High frequency trading. Give me a yes or no, so I can explain if you don't know. Okay, no. So HFT, so they are basically companies. It expands to high frequency trading companies. They basically do the trading, and they have a huge amount of infrastructure setup that helps them to allow people to trade better, stocks better. The good thing is HFT pays massively more than any other MNC, even more than Google, more than anything else you can count of. HFT pays a lot. The hard or the challenging thing is HFT is hard to get because they care a lot about system engineering, system skills. So I had an interview with the HFT company, Tower Search Capital. It's a Gurgaon local company, and there I had three DSA rounds. Right, three DSA rounds. Even I'm applying for a machine learning role. I had three different DSA rounds, and each round gets harder once you clear it. Right, it gets harder once you clear it. So you should not think that okay, if I'm in machine learning, I can skip DSA. You should not, and you will not. Um, Keep both the things in parallel because they are different problems. For example, DSA is teaching you how to make logic of stuff, right? How to think logically, how to solve problem logically. It's like you are doing a mathematical problems. You are learning geometry, you solve problems. Machine learning is basically okay, now you learn those logic, now apply that logic to solve machine learning problems. Machine learning is also built on top of algorithms, right? And these algorithms inside, like if you have a general algorithm, machine learning algorithm, you go inside it, you will see okay, it is nothing but some sort of basic concept, right? So using that concept and apply cleverly into the machine learning, because in the end it's a programming, so you have to use it. So do not skip DSA. I wrote one round here, but it can extend up to three rounds depending on which company you are interviewing to. Yeah, and then there will be a machine learning round, entirely fundamental. If you did the interview section of roadmap, you are good to go. Nobody can even cross question you here. Trust me, I applied it to myself, and I almost never got anything out of the section. So if you follow those resources of interviews very well, you are done here. Then system design, and this comes with experience, and it's mostly likely to be asked in every interview. So the roles I mentioned here will be asked every interview. Don't be like okay, I can skip some roles. It's not going to happen. They will be asked. And the last second round is more inclined towards the projects you did, the problems you solved. For example, if I am competing on a competition, I am designing a system to work there. I'm making a project. I'm designing a system to work here, right? The machine learning system design is completely different to a software learning system design round. Software learning system design have some nice pre-stated things that you can learn. Okay, these things will be asked, and you can learn, and you can just go there, and they will ask you. In machine learning, it is more creative. They give you creative problems, so it only comes in hands-on. If you are able to build, if you are building projects, you have the hands-on thing. You build solving competitions, you have the hands-on thing. So unfortunately, it is completely different than software engineering. There is no predefined path that you can follow. It comes with experiences, and interviewer can ask any creative thing he wants. So if I give example, then in my interviews, I was got asked. So basically, there's an algorithm, and this interviewer changed the algorithm, and he asked me that it is failing now. How to fix it? So such types of questions comes into the experience, right? So you have to be doing things hands on, and then the behavioral round. I don't want to talk about it. So coming to research, okay. First of all, are we clear in engineering part here? I have time, right? 6:18. Okay, I have time. Are we clear till here? Move ahead. Fundamentals. I will recommend till graphs. Dynamic problem. So dynamic programming is not being asked, or if it is being asked, then the the interviewer will be pretty happy to slack you off. Um, in Microsoft Research, I was asked to build a compiler. That is a very stupid question, but the interviewer was pretty chill. That he was not looking at my programming skills; he was looking at my thinking skills. Right. So I will say till graphs. Right, Harsh? If you're able to do till graphs, you will be able to crack all the ML DC rounds. Cool. So in research, everything will be the same, right? Everything will apply here. What can cut off is DSA. It's or if there will be a DSA, then there will be just small Python level DSA, not even doing any kind of logical thinking. But what will be heavily focused is mathematics. So multiple times you will be asked to explain this paper. The interviewer will open a research paper to you, and you will read that research paper, make sense of everything, and then you and the interviewer will discuss about around this paper, what this paper is saying, what the propose. So, and that actually makes sense. You are doing research, you should be having a habit of analyzing and building paper reading that I mentioned in the corner. You have to be very good at maths. um, in my roles, I was asked to prove the loss function of a machine learning algorithm. So the entire thing has to be done with hands in maths and from a very fundamental level. So yeah, that's the thing. And then there will be also some rounds where there will not be any kind of hand involvement at all. The interviewer will put some random mathematical thought, and you will hear it won't be a puzzle, right? You have n amounts, you get n amounts, not a puzzle. It will be a general mathematical level thinking. For example, it will say like, okay, in a linear algebra I have a vector space, and I multiply it with another vector space, but my values don't change. So you will like, okay, that's a very weird question. Identity matrix? No, it's an eigenvalue matrix. So the conceptual clarity matters more here instead of problem solving, right? So you have to be good at both of them, and that's actually a good part. So whenever you're learning for machine learning mathematics, right, I want you to all question the concept from its fundamental core, not be like a JE or 12th that okay, this is a formula, I'll use a formula and get the answer. Try to understand how this formula came, right? Ask every why is possible. So yeah, almost everything will be same, just your focus will be maths will be more. And yeah, cool. You might be having a question on how to build a paper reading habit. We'll talk about later. So should we move ahead? Cool. Cool. I will just try to wrap it up. Okay, now I'm going to give you example of what I did, and it might help you, might not. Who knows? Okay, I started my journey in 2021, right? And in 2021 year, I was not sleeping. I was doing the web development that every other new grad does, and I found out that it's not for me because I was very way too bad in CSS. So then I switched my career to not entirely switched. It's like that course. If you remember that Python course, it was just got launched, and I took it. Um, and from there, I just keep doing the machine learning thing. And then in 2021, I officially get my exposure. In 2022, I did that Kaggle challenge to get the hands on. Then in 2023, I made up my mind that I'm going to become an expert in Kaggle, and I'm going to have a research paper. So you have to preset your mind for the goals of this year. And I set my goals, and then I started reaching out to all the research people I know, cold mailing them that hey, I want to research with you, blah blah. You will shot 1,000 arrows, and most of the times no one will hit a target, but you only want the one that hits, right? So I reached out to a lot of people, right? And I just only wanted a one reply back, and luckily I got a reply back from Hugging Face guy, and then we did the research, and he published two papers. So keep shotting your shot, right? Just don't be like I can wait, I can be up, I can follow the perfectionism, I can learn something first and then I will go to apply. Just keep doing it. Even if you're learning, keep doing it. You will never know what opportunity leads to where. And yeah, so I made sure. And then by December, I we got two papers done. None of them papers were from the college because I was working with a different lab, outside lab. But it finds there is a paper with my name and it helps. Then I in the last 6 months I give entirely to my Kaggle. I compete. So in order to become an expert, I need to solve. I need to get under 10 rank in two competitions, right? And I managed to get them the last 3 months. I become the expert. So in my third year, I was pretty good enough to get a good internship. And then from second to third to fourth year, I just keep doing intern. Sometimes I do internships at multiple places at the same time, right? And yeah, that's all. And let me tell you why it helped. So it helped because um, Microsoft Research has no notion of referrals, right? So it's pretty hard for any guy like from Allahabad University of any guy to come and work here because the referral don't work here. All of my colleagues are from IIT or ISCs or from IITs. The thing that got me here is because one of my paper I did my undergrad are something that they're building on top of it. So I had my paper undergrad and these people are working on top of it. And then they find out, okay, this guy's applying and he's the author, so let's hire him directly. So yeah, you get these benefits if you follow all those credibility checklist. Yeah. So what I wish I have done better is I should be selling more myself, putting out. I had an introversion thing in me back then, so going more in public, showcasing my work more, and I missed a lot of opportunities. Actually, I missed in my first, second, third year. I just kept missing the opportunities because I wasn't aware of them. I started taking them seriously in my fourth year, final year, but I don't want to do that, right? Just be aware, join communities. I mean, you have GDG now, so it's already a kind of announcement to you that this opportunity is coming in. So seek every opportunity you get, right? And track your DSA preparation very nicely. What problems you are doing, where you are weak, where you're not weak. Track everything. Again, not such of perfectionism. You have to be a journalist, right? Don't be like a I will get a perfection score here and then I will move ahead. It's a waste of time. Job descriptions are lies. Yeah, so you have to understand this part. Job descriptions are always lie. Recruiters see what happened is, let's say I'm the team leader. I will say I require this type of person in my team, right? And this message will forward to recruiter, and recruiter will draft a very perfectionism job description ever. Even I do not have that kind of perfect guy in my team, but recruiter don't know about these things, right? They will just draft a perfect job description. So don't be like, okay, am I taking every prerequisite or not? If you're not, it's fine. Apply. Just apply, right? Because if let's say I'm looking for you and you are matching to me, I'm not looking for a perfectionist. I will just hire you. And yeah, reach out to folks. For example, in MSR, there is no referral works here, so you have to reach out to folks personally. And how to do it? Join the conferences, join the meetups, or just talk to them casually on LinkedIn. Interact with them on their post. Give them your thoughts, your points. Right, and take responsibility. Basically, people always have to try to blame some things for their failures, for their miseries. Don't be like that, right? The last point and second last point are connected. You know the system is flawed. You know the system has biasness. Um, Things might work out, might not work out. You don't have to put your energy on the negative things. You just take it as a feedback, construct it yourself, and move ahead. Even if an interview will reject you, will ghost you, just be fine, right? Don't have to be react on it, right? It's a regular thing happens with you. When you get experience, you will see that's a regular thing happening, right? Don't have to react to it. Move ahead. Keep focusing on how you can make yourself better. So have a personal tracker that tracks your own growth, right? So what I did better is I never gave up. I had a lot of rejections on my own. Yeah, a lot of them. But yeah, never give up. Just keep following. Just the process. You might be on a verge that okay, machine learning is not for me. It's too messed up. It's too broad. I don't know anything. I should give up and switch to career. This is fine if you are early. For example, when I switched my web development career, I was in my first year. That's pretty fine. I can do it in the first year. I can do anything in the first year. But if I'm in my third or fourth year, I can't be like, okay, ML is not working for me. I have to switch. Switch to where? I mean, there's no fixed shortcut, right, where you can switch to. So trust the process. If you understand it more fundamental level that from your birth till here, you never learn to walk immediately. You have a sense of uncomfortability, right? So everything you try something new, try something good, something better, you have a sense of uncomfortability, and you have to embrace it. Don't be like, okay, I'm uncomfortable, it's hard, I can skip it. Not gonna work. Right. Yep. Then Q&A. We have 1 minute more. Okay, let's extend it to 10 minutes if you want to, and ask me anything if you have. People. Okay. Should I be oriented towards learning the builder of user site of GenAI in addition to builder? Again, bro. See, there is no GenAI, right? Just forget this term GenAI. I'm telling you, GenAI. So there are people who actually work on machine learning stuff, and then there are CEOs. There are influencers who does not know what is going on, and they just say GenAI or AI, right? So don't fall in that trap. They are just lame who don't know what's going on. And the question says, should I be oriented towards learning the builder of user side of GenAI? I'm not sure what it means. Builders of user side means. You can explain the first question more. I will tell go to the second one, right? ML jobs will keep increasing. Let me give you a thing. See, when people say that this AI is going to eat this career, it's not going to eat the career. It's going to impact the career. Now, what's going to happen? See, let's say I am a programmer and I'm a very basic programmer who's not improving myself from last 3 years, right? Then obviously my job can be done by a automation method much better. But in the same time period, I'm improving myself, and I know how to work in collaboration with the AI, with the automation, whatever the framework it is. There's no way I will lose my job. The other thing is, AI is not perfect yet, right? It is not perfect yet. It will take around next maybe I'm not sure. I think maybe 30 to 40 years to perfect itself. It's not perfect yet. We know we just we just know that this thing prove to work in these scenarios, so let's apply them to everywhere, and that's a bad thing. What's a good thing here is, let's say if I know that AI is going to collaborate with me on software engineering, right? That also means this unstable thing, which is not perfect yet, I am scaling onto a large level. And as something is scaled to a large level, this will require more and more people to handle it, right? So machine learning itself will have a lot of job opportunities in future. You just need to have a right skill set to grab it, right? So I will say even now people are crazy to hire people who work in ML. I personally, so if I tell you, there are a lot of people who reach out to me, whether you know this guy that you can refer. The thing is, those roles are really big roles. So and I also cannot refer some lame guy to the company, right? Roles are there, they are more internal, so that's why companies like Microsoft or any other companies, they focus on to hire from conferences, as I said you, because in conferences highly good minds are there in a particular group, and I'm just going there to grab some of them. So you have to be present in that group, right? Because company invests a lot, billions, and they want this billions should be get handled to someone who is responsible. So yeah, it's skills are needed, but hiring will be definitely not stopping. By builder side, I mean that's how you focus on the functional complexity of the AI. Oh, I see. Yeah, indeed. So there is a actually there's a two mindset here. I will recommend this to do this. I will recommend to follow your approach if you have some experience, right? Um, for example, there's a one mindset going on called vibe coding, wrapper building. So if you're only focusing on the user side, right? And if you did something really good, like for example, let me give you an example, right? If you see Gemini, if you go to Gemini website, you will ask Gemini to make a web app. It will only make the front end. It can't make you the perfect backend database integrated running everything on the server. No, the reason is that there is no backend to provide. So Gemini always write the answer in a plain JavaScript front end. But if you take this problem, it's a problem, right? Take this problem and you say, okay, I will get this front end, and I will make it a backend, right? So now you are actually providing more function, or I would say more flexibility to user. You are indeed building on top of Gemini, right? Gemini is coding for you, but you are providing a more layer of abstraction. This is what I call success. If you're just making wrappers, typical wrappers that don't have anything unique of their own, then they are targeted negatively. So in your early days or in your learning phase or in your undergrad days, basically, I will want you to solve the core problems to get a guest. And as you get comfortable with the experience building up, let's say in the final year, third year, then you can just like, okay, now I am good enough, I can do anything. Because you already gained the respect you needed. Now you have to do anything, right? What's the one? No, yeah, what's one thing you learned? Okay, I think Harsh, that makes sense, right? I'll move ahead. Good question. Hmm. I think I learned almost everything late in my journey. Yeah, so one thing, there is a every year thing that happens in Google called Google Research Week, right? So in Google Research Week, it's it's a Indian thing, Indian Google thing, but the participant can be worldwide. So in 2024, and you cannot just participate, right? It's not like that. What happens is there. Let's say I'm a researcher. I publish some paper, and so if I want to join that research week, I will submit my papers. Not submit. I will just mention them. I always submit them to the globally. I just mention my links, what work I did, and if my work is worth enough to Google, they will they will ask you to come to Google, and you spend a whole 1 or 1.5 week along with researchers, and those researchers will coming from the whole world. Jeff Dean, Manish Gupta, crazily big people will be there. So luckily, in my undergrad I had two papers that were liked by Google, and so I made a chance there. Um, it all happened in my last year, fourth year, and there I got to see everyone, almost everyone there was from top tier college, right? And they had all the opportunities available. And when I'm listening to talks, I'm understanding there's so much opportunities in the wild that I'm not even aware about. There's a Google pre-doc program happens. I'm not even aware about that program, and it happened that the deadline was just 1 week ago. I just missed it from 1 week. So I will say the only thing I missed, I will recommend for people to follow. It's not related to ML, but that will be stay aware in the world, right? Stay aware of all the things going around you. Try to contribute because contribution will give you exposure, and that's a must. Yeah, I mean, still I don't regret it anymore. But yeah, that time it was a huge regret for me. Hmm. How can you roast our community with idea? You don't have to. The strength of ITs and ITs comes from their clubs and their groups, right? Right now, I work with a lot of people here that are from ITs. What I see is their knowledge is limited to what that club is exploring. Let me give you an example. They have very strong infrastructure around building fundamentals. ITs will have a lot of good courses, a lot of good practice sets, and then extracurricular activities, ECCs going on. That all will combinedly make them a good candidate, give them a strong fundamentals. What that not make them a specialist. And I also don't want you to be a specialist, but if you have time, I had a time. If you had time, then be a specialist because that's where they lack. And they lack it. I see it in my eyes. I work with them, and in fact, their team I lead here. So, yeah, if you get a good general knowledge, I will recommend you to be a specialist in one particular area, and that will completely make you stand out from all of these IT people because they are not right. For example, my research work is in the code generation, writing programming codes. So in that time, nobody else was doing it because it requires special knowledge or special skills. So that's the reason I got selected, but some IT knowledge won't get selected. Whew. Okay. How can I go to search problem? Okay. Sachin, I think it makes sense, right? How can I go to search problem? Machine learning or data science? Actually, let me give you one insight here. There is no sense. I mean, if I have to say it obviously, then every problem can be a good problem. For example, there is some trick, some not trick, algorithm that is devised in 2017, which is based on 2023, so 2003 basically. So 2003 till here, 2025, we are using this algorithm very widely, right? It's a, let's say some algorithm X. We are using it very widely in machine learning. But even that algorithm holds a fundamental flaw, right? So, but if you take the name, attention, it's a name. You take attention name, almost everyone knows it, right? Everyone knows what attention is. At least in machine learning, everyone knows what attention is. But still, there's a fundamental flaw, and if you're able to expose the flaw and give a reason why it's happening, this is a good research, right? And these flaws are everywhere. Machine learning is a very unstable field. It just these things are proven to be working, so we use them on a global scale without caring about the limitations or failures. But yeah, almost every problem is a good problem here. What a good problem is not is something that is done by a lot in a similar way. For example, if you'll heard this term a lot, wine classification. It's a wine classification or a Titanic dataset classification. So these are some problems which are done by almost everyone in the beginner machine learning, and they all do it in the same way. And if they all are doing the same way, recruiters know what it is and how naive it is. So if you are also doing it, they're like, okay, he's just a beginner, right? So the notion of a good research problem is something that is niche. It can be niche, right? It can be niche, or it has a wide impact. But you have to do it in a different way. Not if you let's say if I take the same Titanic's problem solution, but I do it in a very different way, and I beat all the previous solutions. This is a good problem, right? You invent something new here. Am I make sense, Ali? This field is pretty unstable, so almost everything you do it in a new way, in a better way, is a good search problem. Just don't copy paste the some previous solution to here. And I mean, the people who are working here, they know it, they will get aware, and they will like, okay, it's a copy paste. Yeah. Anything else, guys? Cool, are you done? Should we stop?
Yes, sir. We think there are no more doubts. So we can conclude the session. And I would like to say, wow, that was such a wonderful session, sir. Thank you so much, sir, for taking out your valuable time and being here with us today. We genuinely appreciate it. You are such an inspiration for all of us, a reminder that we can also reach these heights with dedication and hard work. So thank you so much, sir, again. And on
Yeah.
that note, yes, sir. And on that note, once again, thank you so much, sir. And I would also like to thank our GDG OC JKIAPT team for organizing this event, as well as all the participants for joining today and making this a success. Thank you all.
Bye, everyone.